In a world where gates don't just open with physical interaction, but with the help of AI, we would like to introduce to you Don't Knock It Until You Try It.
Welcome to the presentation. If you couldn't tell before, we had a little bit of a preview of our project. It is a automatic gate opener. It's deemed Don't Knock It Till You Try It. And this was a project for a class we had in school, for an AI class actually. Some of the personnel are Austin Ellsworth, Derek Howland, myself, Hunter Thomas, and Jacob Bourcy. A few things I want to go over before we really get into the nitty-gritty are things that we wanted to look for, and things that described our project. One of which it being simple. The second thing we wanted to do is create something elegant, and then the third thing we wanted to do is make sure it's useful for a few different types of people. One of those things being a business, and the second being an average consumer or like a homeowner. We named it Don't Knock It Till You Try It, as it is an automatic gate opener, and it's kind of a play on words. I'll let you ponder that for a little bit, if it kind of flew over your head. But yep, we'll continue. Some of the technologies that we used were Python, which is kind of a scripting language, YOLO v3, which is an object detection model, and OpenCV. OpenCV is a library that is most of the time used in Python. It has things such as image processing methods, it has machine learning methods, all used for image processing type things. We're going to go a little bit more into depth into YOLO version 3, as this was our main model for vehicle detection. YOLO stands for You Only Look Once. It is an object detection network, and it is used for determining where an object lies in an image, and then it classifies that object. It classifies these objects by placing a grid over the image, and then it predicts multiple bounding boxes around that object. YOLO then makes predictions based on those bounding boxes, and it uses a convolutional network or a CNN for this process. It goes through one neural network versus multiple, making YOLO much faster than its competition, and that is exactly why we chose it over other object detection models. Next, we're going to be giving it to Derek to talk about the motivation.
Thanks, Hunter. So moving on, I'd like to talk about our motivation in actually creating this project. First and foremost, this project was a requirement for our artificial intelligence course. But once we had our group together, we really figured out how much of a role data science, artificial intelligence, machine learning, all of those play a role in today's society and in the future. So this project really allowed us to gain a better understanding of the technologies involved, and understand the processes of what goes on under the hood of an AI application. I had no idea of how to create one. I especially didn't even know that Python was involved. I had no idea what language was used, so this project was an eye-opener for me especially. It was also a very cool project to work on with everyone, and it was a cool project to be able to put on a resume for the future. As for our contribution to society and what we expect out of it, our project being an automatic gate opener using vehicle detection AI, we believe our two largest consumers to be businesses and homeowners. As for businesses, we believe it'll be cheaper in the long run to switch over to our product instead of the conventional ways of parking attendants, and we believe that it'll be safer overall, especially in today's climate of having to social distance, with the constant swapping of parking tickets or vouchers between both parties. It'll be safer to not even have to get out of your car or roll down your window, and just have the AI scan your license plate and pop the gate open, and there you are on your way. So as for homeowners, We believe the largest thing for homeowners would be convenience. In current times, the biggest thing is that garage door remotes, you always have that remote, but what if your remote dies? I've had that happen plenty of times in the last few years where you put a new battery in and, a few months down the line, you forget about it and it dies. It's a convenience thing where you just drive up to your garage or gate and gate swings open or the garage door pops open. No remote involved. You don't have to fumble for it. You don't have to, try and find it if you think you lost it. So that is our contribution to society that we expect, and passing it off to Austin.
All right, thank you. So I'm going to take over and jump on into the method that we used. So we began by getting a working model for vehicle recognition, and in our case we focused on the make and model of the vehicle. Once we had that working, we moved on to a working license plate detection model. And this was extremely useful since this was everything that we needed. Once we merged these two things together, we were able to extract important variables, and we could take these variables and compare them with rows in our database. And once that was done, we tested it rigorously. So I'm going to run you through the code here and just give a brief overview and then a demonstration. So this is our driver file. This file here is meant to basically run everything else. So right here you can see where we access through the database, and this is going to test whether there is a make, a model, and a plate all in the same row that matches what we were able to get from the image. So our license plate model basically is going to open the image. It's trained through KNN under detect characters. It's going to open the image, and then it's going to first try to detect plates in the scene. So this can be seen here, detect plates in scene. We have a method that is going to detect and then give us basically bounding boxes around the plates. Once that's done, we're going to generate a list of possible plates and try to determine the characters within them. And that can be seen here. Detect characters in plates. And here we're going to try to figure out what are the characters in the plate. And if we can read them, then we will output that into both the image that we output for our demonstration purposes, but also into the console. And once this is done, this is taken back to our driver file, where we are going to run our vehicle detection and recognition system. So this here takes in the image, and it will determine whether what the make and model of the vehicle are. And that information is then pushed through into our driver file. And once that information is given to us, we have a access granted or a access denied. So here I'm going to give a quick demonstration of how our program works. So as we can see here in our CSV file we are using currently as a database, we have a Ford Mustang RIP LS1 as the plate. So if we run python driver.py, we're using an argument parser, so we're going to do -i 3.png. This is going to run, and it's going to spit out an image here. So as you can see, this is a Ford Mustang, a 2003 or 2004, and the RIP LS1 plate is indeed here. So once this is put into the console, we're going to get a result: make Ford model Mustang plate RIP LS1. Access is granted, and at this point we can determine that we want to open the gate for this vehicle. So next, I'm going to demonstrate what happens when a vehicle is not in the database. So we'll want to do a separate vehicle here. I actually have this one in a separate folder, plate images. So now this example is also going to be a Ford Mustang, and we have PNYEXPS. Now, as we can see, before we get any output here, we can kind of see what's going to happen ahead of time, because if we look through our database here, we do not see PNYEXPS. So we should get an access denied. Once we close this, we indeed do. Access denied. Call gate security for access. And this is the point, is that as long as we put someone here in our database, they should be given access, and vice versa. If they don't have access, or if they don't end up in this file or database, then they will not be given access and the gate will not open. So now, as you had already seen, our results. So this is obviously the vehicle I demonstrated earlier that is in the database. So it was very important that we were able to extract this information from both of our models at the same time to generate this result. And here's an example of a vehicle that is not in the database. This is just another example. So this is the BMW M5 NYSJ. And as we can see, we do not have that one currently in our database. So access is going to be denied. Now, if we did want to put this one into the database, we could. All we would have to do is enter in BMW X5 NYSJ. We can save this, and if we run through our license plate pictures here, we can see that this one is number 6. So now, if I run this with 6, there's our output, and to the terminal, access granted. If I was to remove again and run it, since it's not in the database this time around, access denied. So this is a relatively simple way to handle this database. Obviously, in a real life application, we wouldn't want to be using a CSV file, but it definitely gets the point across. Now for our validation and testing, we had a few options here. We also have a working model for a video feed, but for this specific application, there's really no need to have a continuous vehicle recognition system that runs off of a video. So in this instance, we chose a single photo. It's much faster, so you don't want to pull up to a gate and once the sensor goes off have to wait for 45 seconds to a minute just to gain access, because the video is, chopping through and slicing the video into separate images just to determine the same information you can get from a single photo. Next is our separate models versus merged models. Now, we kind of merged our models by just using one file to bring them together and call each other. So we would consider that a merged model. Rather than having to rely on the output from one and then have to call another one, we actually have them merged, and this was much more efficient, we found, and also there could be a need for human input if we had them separate. So that definitely worked better for us. So now I'm going to pass this over to Jacob.
The major shortcoming of this project was a mixture of the inability to meet in person and the time constraint. While we were able to make the most of our online environment, in-person meetings would have allowed use of a camera for detection. The more we worked, the more exciting the project became. More time would have allowed for more polishing. This includes added features and real-life project demos. Given more time, we would have liked to incorporate a sensor and a camera. We would also like to have increased the accuracy of the plate reader while also running more tests on harsh conditions such as snow and rain.
Alright, so one of the last things I'm going to talk about here is the project management. I'm going to go over everyone's role throughout the semester. I'm going to start here with Austin. Austin was a key contributor. He ran all the code on his computer because he had a GPU, and YOLO version 3 model is most efficient when ran with a GPU, so the rest of our computers would have taken forever and it wouldn't have been necessary, it wouldn't have worked. So he had all the code in his computer, and that means he was responsible for testing and running the code. And not only was he helpful with all that, but at the end of the day, he also did valid research and he helped a lot with the final report and the presentation. Myself, Hunter Thomas, I was designated to be the team leader in the beginning of the semester. My main portion was doing heavy research. I was the one who found the YOLO version 3 model and all the pre-trained models actually that we used for this project. One of the things that I did as well was every time Austin was on running through code or putting things together, I was right on with him. I was kind of a second pair of eyes whenever he was going through something tough or had an error. I would try to help him find it. The next person that we're going to talk about is Derek. Derek was a very large contributor as well, as he was also involved in doing research, and he was also a second pair of eyes when we were going through the code and helping troubleshoot errors. Jake was doing the same thing as well. He also helped me out doing research and finding models, and he also went through the code and we were all going through it. Everyone was a huge help in the project. No one was a liability. Everyone was a key contributor to the final result. I couldn't have been happier with a group. Everyone performed awesome. It was a great experience. We all got some good real world application of AI, and I think we all have a deeper understanding of how everything went. Alright, we're gonna give it to Jake to talk about the conclusion.
The goal was to use AI technology in a real world application. If we could do it again, we would attempt to integrate a camera and a sensor into our model so that it can be used in real time. We would also have liked to have been able to develop and train our own model from scratch, but unfortunately, we did not have the time or the resources. We feel we learned a lot about the structure of neural networks and how to integrate them with each other to complete a task. We also learned a considerable amount about the applications and usefulness of Python.